Welcome back. In this video, we're going to work with formulas and solving for a particular variable within a formula, and we're also going to do some quadratic word problems. So, for example, we might have something like the area of a circle. Area equals pi r squared, and we will want to solve that for r. Well, like we did with solving using square roots, we're going to want to isolate r squared. So we'll go ahead and divide both sides by pi. And we'll get r squared equals a over pi. Well, we want just r, not r squared, so we'll use the inverse operation of squaring, which is taking the square root of both sides. And I'm just going to take the square root of both the numerator and the denominator there. And solving for our r, we get r equals plus or minus the square root of a, or the area, over the square root of pi. Well, we don't like square roots in the denominator. That's irrational. So we have to rationalize that and multiply by square root of pi over square root of pi. That leaves us with r equals plus or minus the square root of a times pi all over, and of course pi, radical pi times radical pi, or square root of pi times square root of pi is pi. And that is our final answer for r. Our second sample problem, we want to solve s equals 30 times the square root of a over p for a. So similarly, we want to go ahead and isolate the square root. So I'm going to divide both sides by 30. So we get the square root of a over p equals s over 30. Well, now I want to do the inverse operation of the square root. So now I'm going to square both sides. So we get a divided by p equals s squared over 900. And we're looking to solve for a. So I multiply both sides by p. We end up with p times s squared all over 900 is equal to a. A equals ps squared over 900. Let's move on to some word problems. A ladder is leaning against a house. So in our diagram we have a house. Houses hopefully form right angles. And we've got the ladder leaning up against the house. The distance from the bottom of the ladder to the house is 5 feet. So it's 5 feet from the bottom of the ladder to the house. 5. The distance from the top of the ladder to the ground is 1 foot less than the length of the ladder alone. Well, we don't know how far it is from the top of the ladder to the ground, and we don't know the length of the ladder. So the ladder in this case is our x. That's our unknown, and the length from the top of the ladder to the ground is 1 foot less than the length of the ladder alone. So that dimension would be x minus 1. We have a right triangle here. We have one variable. We can use the Pythagorean Theorem to help solve our answer. Of course, our Pythagorean Theorem says leg squared plus leg squared equals hypotenuse squared. So 5 squared plus x minus 1 quantity squared equals x squared. A squared plus b squared equals c squared. Now be careful here, because x minus 1 quantity squared is a perfect square trinomial. It is not x squared minus 1 or x squared plus 1, but it follows the pattern of a perfect square trinomial. It's x squared minus 2 times a times b. So minus 2x plus 1 equals x squared. And now we want to solve for x squared, or maybe even solve for x, because if we subtract x squared from both sides, those are going to drop out. And 25 plus 1 is 26. We get negative 2x plus 26 equals 0. Add 2x to both sides. We get 26 is equal to 2x. Divide by 2, and we get x equals 13. So x equals 13. That is our ladder. And the height is x minus 1, or 12. So how long is the ladder? The ladder is 13. So we have followed our instructions. We've got our diagram. We wrote an algebraic equation. Here's my algebraic equation. It was the Pythagorean Theorem. We solved that, and we answered the question. So even though we had x squared, since our x squareds drop out, we didn't need to square root both sides. We didn't need to complete the square. We didn't need to factor, and we didn't need to use the quadratic formula, which are all possibilities when you're solving for x squared. Let's take a look at our next question. A rectangular pool is 40 feet long and 20 feet wide. A 700 square foot sidewalk border of uniform or equal width surrounds the pool. So I've got my pool here, my pool that's 40 by 20. And then I've got this uniform border all the way around my pool. It's of equal width. It's the same width everywhere, but we don't know how wide it is. We want to determine the width of this particular sidewalk. So that's our unknown. It's x. And it's x to the right of the pool, and it's x to the left of the pool. So as it turns out, this dimension, this length, while it's 40 from matching the width of the pool, we have to add an x dimension on each side. So the length of the pool is 40 plus 2x, x on the right and x on the left. And we do that same kind of concept here. So this length is 20, but we still have this distance x and x. So the dimension, our width of our pool is 20 plus 2x. The 20 of the pool plus the x on each side for the sidewalk. So we know our pool is 40 by 20. The pool's area is 800. The area of the sidewalk, the yellow all the way around, is 700 more. So my entire length and my entire width equals my total area, the 800 plus the 700. So my length times my width equals the entire area. So from this we can write our equation. So we have 40 plus 2x times 20 plus 2x equals the area of the pool, 800, plus the area of the sidewalk, 700. That's our total area. So our total area is 1,500 square feet. Something interesting here, I have a common factor in the 40 plus 2x. I can factor a 2 out of there. That becomes 20 plus x. And I can factor another 2 out of the 20 plus 2x, and that's 10 plus x. and that equals our 1500. So if I factor 2 2's out, that's factoring out a 4. So I'm going to divide that out. Divide both sides by 4. 1500 is divisible by 4. So I'm left with 20 plus x times 10 plus x equals 1500 divided by 4 is 375. Now, I want to solve this, so I'm going to have to FOIL this first. So I multiply this out. I will get, well, you know what? I'll rewrite it for you. It's x plus 20 times x plus 10 equals 375. 10 plus x is the same as x plus 10. Now it's going to be easier to FOIL. We get x squared plus 30x plus 200 equals 375. We have to set one side equal to 0. So we get x squared plus 30x minus 175 equals 0. Now, this is probably factorable, but I'm going to go ahead and I'm going to solve this by completing the square. So I get x squared plus 30x plus my blank equals a positive 175. And this becomes 1/2 of 30. So 30 times 1/2. So that goes up here. That's 15 squared. So I am adding 225 to the other side as well. So my perfect square trinomial becomes x plus 15. 20 squared equals, and 175 plus 225 is 400. I will take the square root of both sides. Get x plus 15 equals plus or minus 20. And x, my width, x, is equal to negative 15 plus 20. And x is equal to negative 15 minus 20. So it's either 5 or it's negative 35. Well, we're not going to have a negative width, so our width is 5. So we've completed the square. Obviously, we could have factored that, but we get x equals 5. That is the width of the sidewalk. So there's an example of using quadratics to solve word problems, and then using your skills of either the quadratic formula or factoring or completing the square to solve and answer our questions. And we will see you in class.